gonna start today with linear regressions, so anything that is gonna give you a straight line at the end, okay? Tables, graphs, and equations are all examples of mathematical models, right? We've seen them yesterday. We saw the tables, we saw the graphs, we saw the equations, right? We looked at them, but today we're gonna compare some of them. We're gonna look at some of them and say, by looking at it, I know this is linear, okay? By doing a little bit of work, I know this is linear, okay? So, we're gonna look also at the quadratic, and tomorrow you guys are gonna look at the exponential. Okay, so these are the three models that we're gonna look at. Now, when I say a linear model represents quantities that increase or decrease by a constant amount, right? So when you're talking about, let's say, your salary, right? If you're paid by hour, right? Every hour you get paid $15 an hour, right? So every hour you're increasing by 15. So that's called a constant increase, right? So constant amount over equal interval. Which in this case, in the example that I just giving you, the equal intervals are every hour, right? So every hour is an equal interval. I'm missing something here, and that is in a table of values, the first difference is constant, right? So for a linear function, when you are given a table of values, right? And you do your first difference, if it's linear, your first difference is going to be constant. What do we call the graph? What do we call the graph of a linear model? What do we call it? Straight line, right? So you'll see it in a graph as a straight line. Do you remember how the equation of the line is written?
Why is it greater?
It's a line, so it's not a quadratic. So what should your degree be?
Degree 1.
Degree 1, right? So it's y equals mx plus b, right? So this is called this form is called the slope by intercept, where m is the slope and b is the vertical intercept or the y-intercept, okay? So when you look at an equation and x has an exponent of 1, or which in this case it's an invisible exponent, right? You know right away that it's a linear function, okay? So this is how we're going to be able to compare the different equations. What other word can you tell me about the rate of change? So rate of change is the same as what? Rate of change is actually the slope.
Slope, yeah.
Right? Which is similar to the first difference, right? But it's divided by the x interval. Okay? So basically the rate of change is going to have to be what?
Raise over run.
It is the rate over run. And would you see that would it be constant or would it be changing for a linear function?
Constant.
It will be constant. Right? So the rate of change is constant for a linear function. Okay? So, recap. Graph is a straight line. Equation would have a degree of 1. Okay? The first difference is constant if you have a table of values, and the rate of change is constant, right? Because it's the same as the slope. Okay? So all what you have to do, if you are given a table, you have to do the first difference to know if it's linear or not. Okay? If you are giving an equation, you just have to compare it to this equation. Does the x have a degree of 1? Then it's linear. Okay? So let's look at this. Which model represents linear relations? So since it's a table of value, I have to do
Difference.
first difference. Okay? So let's do first difference here. With the first difference, you have to do this minus that, right? So it's 55 minus 60, which is negative 5. Do the same thing. 40 minus 55. What do you get? Negative?
Negative 10.
Can't be 10. Yeah. Yeah?
Yes.
Okay. 15 take away 40 is negative.
Negative 25.
So what can you tell me about the first difference?
It's not constant.
Not constant, that means it's not linear. Okay? First difference, not constant. Therefore, not linear.
The next one is constant.
So 40 take away 0 for the next one. 80 take away 40. And then 120 take away 80 is 40, right? Because the first difference is constant, that means it's a linear function. Okay? So anytime they give you a table of value and they ask you to determine if it's linear, now next time it's going to be linear, quadratic, or exponential, right? Whenever you do the table of value, first you start with the first difference, right? If the first difference is constant, then right away you're going to say it's linear function. Now it's not. If it's not constant, usually in these questions you're going to see later on that we're going to have to move to the second difference, right? Because if the second difference is constant, that means it's quadratic. And then if neither are constant, then we have to do the exponential test. Okay? So, but in this case, all what we care about for now is it linear or not? Okay? Now, if you look at the graphs, can you tell me the first graph is linear or not?
It's linear.
Yeah.
because
It's a straight line. So it's a linear function. And how do you know? Because it's a straight line. How about the second graph?
It's not linear.
Not linear, right? Because it's not a straight line. It's curving, right? Now, if I look at the equations,
It's linear with vertex.
let's say the first one is a degree 1 on the x, right? And it looks like y equals mx plus b, right? And the most important thing is its degree
One.
1,
Yeah.
right? So that means it is linear. Okay? What can you tell me about the second one?
That's not linear.
It's not linear because it's a degree
Degree 2.
2, right? So you see the degree right here is degree 2. So it's not linear. Later on, we're gonna have to specify, and then we're gonna have to say the x quadrat. Okay? But for this question, it's just asking you, is it linear or not? And then the answer is yes or no. And why? You always have to explain why, right? Are you guys okay with this? All right. Now, when we're talking about analyzing the graph, okay, so when we're looking at a graph or when we're looking at an equation, at a plot, we're looking at the, we're looking at the y-intercept and at the slope of a line, okay? These are the two features that the lines are, you need to find the equation of a line, okay? So remember that y equals mx plus b. Right? Where m is the slope and b is the y-intercept. Okay? That's basically all what I need to create an equation of a line. So the vertical intercept or the y-intercept represents the initial value of the dependent variable. Okay? Because remember that this is when at time 0.
Yep.
Okay? So if you're looking at this, at time, let's say this is height, for example, and this is time, okay? This right here is at time 0, so that's when you started or at the beginning, okay? So this is called the initial value of your dependent. The slope is the rise over run, but it's also called the rate of change, right? Remember, these words are the same, right? When you see rate of change, I'm talking about the slope. The difference is the rate of change have a unit, slope doesn't have to have a unit, okay? So the slope represents the rate of change. In the dependent variable with respect to the independent variable, which means that is delta y over delta x, okay? Delta means the difference between y over the difference between x, which is the same thing as y2 minus y1 over x2 minus x1, which is the same thing as rise over run. And these, all of these you should have seen before. You should know these.
Yeah.
Okay? All right. Now, let's read example number 2. So, a cup of coffee is reheated in the microwave. The temperature C degrees Celsius of the coffee after T seconds can be modeled by the following linear equation. Explain what the numbers in the equation represents. How do the two equations compare to each other? So if I heat it in a microwave that says on it 500 microwave, 500 watt microwave, the equation is C, so that's the coffee temperature, equals to 0.5 T plus 20. Okay? So 0.5 T, that is, T is in seconds, right? So how many seconds did I heat it? Did I put it in the microwave? Did I put it for 30 seconds? Did I put it for 40 seconds? Okay? Now if I look at the second one, which is this 1000 watt microwave, it's C equals T plus 20. Okay? Can you guys compare these two equations for me? What do they have the same, what do they have different?
They have the initial value,
The initial value, which is what?
0.5.
Initial value, 20, right? 20 is the initial value, right? Remember that this is the y-intercept, right? So 20 is your y-intercept, which is your initial value. So that means your coffee temperature right now, at the beginning, is 20 degrees Celsius, okay? So you're gonna take that coffee, put it in the microwave, okay? Now, You put it in the microwave for I don't know how many seconds. Okay, so that's T. Right? Now what's happening for every second? What's happening to the temperature every second for the first microwave?
It's increasing 0.5.
That's right. So every second, your coffee temperature is going to increase by 0.5 degree. So that means after 1 second, your temperature is going to be 20.5. After 2 seconds, it's going to be 21.
Okay.
3 seconds, it's going to be 21.5. So you're increasing by 0.5 degree per second. What do we call this?
T times per second.
So what do we call it? That's a unit.
That's
Degrees Celsius per second.
yeah.
But what do we call the word? What's a word called?
Rate of change.
Rate of change, right? So your rate of change, your slope, it's increasing by 0.5 degree per second. Do we understand that? Now how about the next equation? This equation.
It doesn't have rate of change.
It does.
It's not constant.
Oh, T.
It's constant.
Oh, it's 1.
It's 1. If I don't see it, it's there,
Yeah.
right? It's 1. So what's happening to your temperature here?
It's increasing by 1
1 degree Celsius every
every
second.
second.
That
Right?
is constant.
Both of them are constants, right? This is 0.5 degree per second, right? So it's increasing by 0.5, right? But in this case, it's increasing by 1. So this is a little bit, not a little bit, this is double the power, right? This is gonna, so let's say if you want your temperature to be only 30, right? You just have to put it for 10 seconds in this microwave. In this microwave, you have to put it for 20 seconds, right? Because it's only increasing by 0.5 every second. Okay? So you see that these two equations are similar, but they're different, right?
Yeah.
One has a higher slope, right? The slope here is the slope of the second equation is higher than the slope of the second equation. Okay? So let's write down what I want you to write down. I'm gonna type it. So the coefficients of T, which are 0.5 and 1, are the rate of change of both temperatures with respect to time. So we have 0.5 degrees Celsius. I don't know how to write degrees Celsius. In the 500 watt microwave. And 1 degree Celsius per second in the 1000 watt microwave. The constant 20 in both equations is the initial temperature of the coffee at T equals 0 seconds. Are you guys good with that?
There's no equal.
I know. I was looking at it. I'm like, that doesn't look right. Thank you. Are you guys good with that? All right. So far we were looking at just equations, and then we're trying to understand what the equations tell us. But if we have data, which most of the time when we collect data, we're gonna collect points, right? So we're not gonna collect an equation, right? We're gonna collect points, and then we're gonna have to graph them, and we're gonna have to see what kind of relation do these points have, okay? So we can use what we call linear regression, okay? And that is called, regression means it's like the line of best fit, okay? To model data that appear to be linearly related, okay? It's the line of best fit. So if I have let's say few data points, right, and then they look like this, which is kind of linear, right? So all what I have to do is kind of find the line that best fit all these data, okay? Thank God we don't have to do this by hand anymore, because we do have technology that can do that for us, okay? Who wants to do that by hand, because that will take forever, and then it's not as accurate as it should be. So we're gonna use Excel to do that for us. So what we can see for the next question. So let's read the question. The following table shows the median age of the population from 1975 to 2000. Okay? And use a graphic technology to create a scatter plot of the data. Draw a rough sketch of your scatter plot here and describe any trends. I'm gonna show you how you're gonna actually, instead of drawing it, you're gonna snap it. So this way you don't have, like, when you do your assignments, you know how to snap it and put it in your assignment. Okay? So I want you to open a Word document and an Excel document. Now, in the Excel document, we're going to enter these data. So I'm going to show you how to enter them. Let me open Word as well. So in the Excel, you guys see? So in the first column, I'm gonna write year. And then in the second column, I'm gonna write age. Under year, we're gonna enter the year, so 1975, 1980, 1985, 1990, 1995, and 2000. And then in the age, make sure that you enter your data correctly, because a lot of time, this is what's happening, is that they're not entering their data correctly. 29.1, 31, 32.9, 34.8, and 36.8. Can you guys see, or should I make this bigger? Make it bigger. Let's see. Where is the zoom?
Sit down.
Are you guys okay with this?
Right.
All right. So here's the steps. You're gonna have to highlight the data only. Don't highlight the titles, just the data. And then you're gonna go to insert. You're gonna press on that. You see that chart right here, that thing right here, the scatter plot. And then you're gonna just pick the first one, which is the scatter. Okay? Can you guys see that? You guys see the same thing? Now, these are my points that you see right here. You see how this is too high up, right? We have to kind of better scale our axis. So what we can do, we can always change our scale by double clicking at the axis. So when you double click at the axis, you're gonna see something like this pop up, right? Is that what you guys have, all of you? If not, then you have to press on that bar thing right here. You see it? You see that bar, the 3 green bars? Okay. Now, I'm looking at the axis, at the vertical axis. My maximum is 40, which is fine. But instead of starting at a minimum of 0, I'm gonna start at a minimum of 20. Okay? Because my lowest point is 27.4. Okay? So I don't need the 0 to 20. Why would I want my graph to be so high up? So if I do that, look at how my graph is right now. You see? It's not only like placed on the top corner of the scale. Are you guys okay with this? Now this step you don't have to actually technically do, but it would look nicer. The graph would look nicer if it's not crowded. Now, another important part is your label. Okay? So if you press on the graph, just press on the graph, you should have a plus sign. You see the plus sign? Press on that plus sign, and then you're gonna have axis titles. You must add that to it, because I wanna know what these axes are. So for this one, it's gonna be median age, or age, you can even put age. And then for the title of axis is year. And then a chart title. Okay, so the chart title would be, you have to read what the questions say. Median age of Canada's population. Median age of Canada's population. Okay, so now I have a graph that has axis title, has a title itself, right? And that looks nice, it looks good. Now, can you tell me if it looks linear to you?
Yeah.
It does look linear, right? So now, to enter the regression, eyes on the board for a minute. So you're gonna press on one of the points, doesn't matter which point, then all the points are gonna be highlighted. Right click, you're gonna see add trend line. You guys see that? Press on add trend line, and then you're gonna see the different options that you can pick from. Because I know this looks like linear, I'm gonna press the linear one. It doesn't hurt to look at different ones, right, and see how it changes, but I would say linear is the best. Display equation on chart, so you have to, at the bottom right here, you have to press display equation on chart, and also display R squared on the chart. So you're gonna see a box that appears on the graph with an equation, as well as with the R squared. Okay, the R squared is a very important indication of how well your line, your regression line, is fitting your data. Okay, the closer the R squared is to 1, the better the fit. Okay, so in this case it's 0.9995, right? So that's a very, very, very good fit. Okay, that means that the regression that you picked, the linear regression that you picked, is a good regression. Okay, I'll show you, I don't know if that would work here, but let's look at the regression line. Let's see a polynomial, not a polynomial. They kind of all look good. Anyway, we know that we want a linear regression. Okay, so your equation is 0.3771x minus 717.57. okay? Which means that your slope or rate of change is 0.3771, okay? All right, now, how do you copy this into Word? You're gonna have to look for a snipping tool on your computer, and I'm sure it's available for snipping tool, right? If you own an Apple, you have to do Shift-Alt-4, I think, and take a picture. In this case, you know, you do the snipping tool, so you're gonna create a new snipping, and then you're gonna just new snipping, and then you're gonna take a picture if you want of your graph, right click, copy, and then you're gonna go to your Word document, and then you're gonna paste it wherever you want to paste it. Okay? So using the snipping tool, if it's not Apple, if it's Apple, I believe it's Control Command 4, if I'm not mistaken. Let me see. This is using a Microsoft. Yes, it is a Mac, but it's using a Microsoft. So, any of you are going to be using Apple?
Yeah.
Product? Mac?
Yeah.
Okay. So you know how to do it? How to take a picture? No? I'll tell you. Just 1 second. In the meanwhile, you guys try to do what I just did. So it's Shift Command 4. Shift Command 4. Do you want to come and see? So if you do Shift Command 4, you'll see this, the cursor. You highlight whatever you need to highlight. It's going to take a picture, a screenshot, and then we'll put it right here. So all what you have to do is you can copy that. You can copy it, or you can drag it and drop it into the Word document.
Okay.
Okay?
Okay. Thank you.
So it's Shift Command 4. Are we okay with this? Is everyone okay? Yep.
Excuse me, I want to know that how did you,
How did I?
is it started from 0 in the beginning? The chart was started from 0?
Yeah.
You made it from 20.
Okay, I will go back there. So what I did is I double clicked on the vertical axis,
Okay.
and then I
Okay, that was numbers.
there is a way that you can go here. Where is it? No, wait. Okay, so I double clicked on the vertical axis, and then I went to the chart right here, the 3 axis options, and then I wrote 20. You got that?
Okay.
But when we are double click, it's giving
What is that giving you?
all text.
Oh,
Double click on the axis itself.
yeah.
That's weird. Oh, because you're not using Excel, this Excel. You're using the online Excel. Don't use online Excel because it doesn't give you all the options. use the Excel that's downloaded on your,
Okay, on my computer.
yeah. Don't use online Excel because it doesn't give you all the options, okay?
Okay.
Why did you add the title?
How come you have it framed? Okay, because you picked a different regression, right? They needed that to clear. So I'm gonna just do this. Add trend line. Okay. We had push on. Okay, so double click. Okay, so that's done. Okay, in order to add access, which is a highlighted thing, you're gonna get that plus. And then you're gonna say access on it. Are you guys okay with this? All right. So remember that you can access the video online, and then that will tell you exactly what you need to do after. Are we all good? Okay. Now, if I want to go to, I've already know what the equation is, right? If I want to answer C, so predict the median age of Canada's population in 2020, I can use two different methods. I can use the regression equation or I can use the regression line, okay? When it's with the regression line, it's a bit hard because basically I'm ending at 2005. Right? So if I want to extend this line, right, the extension won't be visible because my graph would not show me where 2020 is. Okay? So it's a little bit harder to do this on a graph like that. Okay? Unless what you can do is you can go into Excel and go into your x-axis and then make it end at 2020. And if you look right here, now you can actually, and then make your x-axis a little bit higher than 38, so make it at, let's say, 45. So you're changing your axis, so this way when you actually draw a line, a regression line, you're going to be able to kind of determine where 2020 is going to be. Okay, so it's a little bit harder. So what I can do here is I can actually kind of extend that line right here, right, linearly. I can't do that by hand. Okay, and it looks like in 2020 it's going to be about 44 years, but this is not accurate. Okay, can you guys just pay attention to me for a minute? This is not accurate, so the best way to do it is to actually use the equation that we have gotten from Excel. Okay, so the equation is y equals 0.3771x minus 717.57. So I'm going to write that. Can you guys repeat that for me? Because I don't know. So what's the equation again?
Y is equal to 0.37. And x minus 7.57.
So I'm looking at the age in 2020, right? So that 2020 is the x value. So all what I have to do is I have to replace x with 2020. And then solve for the answer. Okay? Which is what is it going to give you? Should give you about 44.2. Or 44, yeah, 44.2. looking at the graph and the blue line, I said just below 45, right?
Yeah.
So it kind of is close. Okay? But which one's more accurate? The equation of the line,
Okay.
right? Do you all understand what's happening, what's going on?
Yeah.
Alright.